All right, 5.5, number 2, it says the integral from 2 to 3, we start at the bottom, from 2 to 3, of x squared, that's your function, dx. And I've written it down here, so what we're going to do is first find the antiderivative of x squared. And we know that that's x to the third over 3. Very simple little function there. And then I'm going from 2 to 3, so I always draw this and put this in the same order. Then we're going to plug in the 3 and plug in the 2, and that gives me 3 to the third over 3 minus 2 to the third over 3. I did this beforehand, and I got 6.3333. All right? Now if I take a look at what this means over here, I've graphed the function y equal x squared. Right there, I just didn't need this part because we're integrating from 2 to 3. So we have calculated, I'm talking about the exact area under the curve from 2 to 3. So that is this area right here. So we have a way of finding the exact area. Remember before we were using all these rectangles. It turns out the fundamental theorem of calculus puts together the antiderivative and finding these areas and that they are related. All right? That integral, which gives us an antiderivative, evaluated at the endpoints will give us the area under a curve. Pretty cool. Let's try this one. The integral from 0 to 1, excuse me, of e to the x dx. Well, the integral of e to the x is itself, and then we're going to go from 0 to 1. If I put 1 in there, I get e to the 1 minus e to the 0, which is what? E minus 1. And I got that's about 1.718. And all of these I've already graphed. You can put these on your calculator. And going from 0 to 1 will be from 0 to 1. That is this area. So when I ask you to graph the area, that means you shade it. Okay. That's the exact area there. Let's try number 4. The integral from 1 to 2 of 1 over x dx. Well, the integral of 1 over x is the ln of the absolute value of x from 1 to 2. So this gives me the ln of 2 minus the ln of 1, which is about, I did this before, let's see, 4 is about 0.69. And now, and notice that I plugged the 2 in, and absolute value of 2 is 2, that's why I didn't put the absolute value. And then I put the 1 in, and just wrote ln of 1, because absolute value of 1 is 1. You can put the absolute values in if you want. Now over here, I graphed 1 over x, and you can do this on a calculator by hand, and we're looking at the area from 1 to 2, so we're talking about this area right here. All right, last one, number 5. The integral from 1 to 4 of 3 squared of x dx. Now this one, we're going to have to rewrite. So we have to use our integrating skills and rewrite 1 to 3, 3x to the 1/2. And then that becomes, now that I have it in the proper form, I use the power rule. So I add 1 to 1/2, that's 1.5, which is 3/2, over 3/2. And we don't have to put a plus c, we're just going to go from 1 to 3. I am going to flip that up there. What does that give me? A 2. If you take 3 divided by 3/2, use your calculator if you're not comfortable. And then I'm going to put 2 parentheses, I'm going to put the 3 in for x to the 3/2, minus, and then put the 1 in. So it would be 2 times 1 to the 3/2. And I got 14. I did do that ahead. All right. It's kind of clunky with the calculator and the iPhone trying to film. All right, so now from 1 to 4, we've just calculated this area in here. There you go. That takes care of section 5.5. See you later.